Good day everyone. So we are the group 1 and we are assigned to discuss exercise number 6 entitled Randomized Complete Block Design. But before that, let me just introduce myself. I am Raymar Kansa Abalayan and I will be the first reporter of this activity or exercise. So what is Randomized Complete Block Design? It is one of the most commonly used experimental design, specifically in agricultural research. So it is the design which the researcher would use if he could not obtain or locate completely homogeneous experimental units. When we say homogeneous experimental units, these are the units that are uniform as possible on all characteristics that could affect the response. So in RCBD, the experimental units are grouped into R blocks, or R, which is equal to the number of replication, which is equal to the number of blocks. So in such a way that each block would contain more or less homogeneous experimental units. So RCBD is most appropriate for field experiments where the number of treatments is not large and the experimental area has a predictable productivity gradient. And also it is a two-way classification because we are not observing or testing for one effect, but we are testing and observing for two effects, namely the block effects and the treatment effects. Now, to fully understand RCB design, we're going to solve or answer the problem given. So, an experiment using an RCB design will be conducted to determine the effect of farmyard manure and inorganic fertilizers on the green yield of corn. So, the treatment in 4 replicates R or our blocks are the following. So, these are the data or information based on the given problem. So, we have the treatment code and the treatment description. So, in treatment 1, we have the control or no fertilizer up to treatment 6 with its treatment description 10 tons FYM plus 630-30. So the grain yields of corn tons per hectare as affected by the application of farmyard manure are the following. So from treatment 1, replication 1 or block 1, we have the value of 2.85. Up to treatment 6, replication 4 or block 4, we will have the value of 5.65. But before jumping on the calculation, we'll first indicate the item and numbers for our replication, treatment, experimental units, and response variable. So for our replication, we have the number 4. And for our treatment, we have the item farmyard manure and inorganic fertilizers with its number 6. And for our experimental units, we have the item blocks with its number 24. And for our response variable, we have the item grain yields of corn tons per hectare with its number 24. Now, to give a possible randomization result and to illustrate the possible layout of the experiment, we're going to generate random numbers with the use of our scientific calculators and other platforms to get random numbers. And after, we will going to decide or we're going to arrange it depending on our choice if it is on descending or ascending orders. So in here, I have already generated random numbers and I already rank them in ascending orders or from lowest to the highest numbers. So in block 1, we will have these generated random numbers. We have 873, 349, 214, 452, 69, and 793. And their rank orders is 6, 3, 2, 4, 1, and 5. So the same procedure and process in block number 2 and also in block number 3 and also in block number 4. So these generated random numbers and rank orders are very important in giving a possible randomization result and also to give or illustrate the layout of the experiment. Now, to give the possible randomization result, we'll utilize this table. So in the first column, we have the treatments, and in the second, third, fourth, and fifth columns, we'll have the experimental units assigned or the blocks from block 1 to 4. So in treatment 1, block 1 to 4, we'll have the experimental units assigned 6, 4, 2, 6. Up to treatment 6, block 1 to 4, we'll have the experimental units assigned 5, 1, 1, 3. Now, to illustrate the possible layout of the experiment, we all know that we have 6 treatments and 4 replication. Now, multiplying these values will give us the total number of our experimental units, which is 24. Now, to illustrate the possible layout of the experiment, we all know that we have 4 blocks and we have 6 treatments. So in block 1, we have the treatment 6, treatment 3, treatment 2, treatment 4, treatment 1, and treatment 5 up to block 4, which we will have these treatments. So treatment 3, treatment 4, treatment 5, treatment 1, treatment 2, and treatment 6. So this is now our possible layout of the experiment.
Hi everyone. So before we proceed to our discussion, let me introduce myself first. I am Chavi Faith R. Carsado and I will be continuing the discussion. So after the illustration of the possible layout of the experiment, we will now state the null hypothesis and alternative hypothesis for the blocks and treatments. So for the blocking, we have in null hypothesis, there is no block effect, while in alternative hypothesis, we have there is block effect. Further, in treatment, the null hypothesis is written in such a way that there is no treatment effect, while in alternative hypothesis, there is treatment effect. So after stating the null hypothesis and alternative hypothesis, we will now jump into the next slide. Present the data on grain yields of corn in tabular form. So in this problem, we have given 6 treatments of fertilizers applied to the plants with 4 replications or blocks. So under the treatment 1, replication 1, we have 2.85, T1 replication 2, 2.75, T1R3, 2.80, and T1R4, 2.70, and so on until to the treatment 6 replication 4, 5.65. So in this table, we also derive the totals and means of each treatments in 4 replications. So in treatment 1, we have 11.1, 13.37 for treatment 2, 17 for treatment 3, and so on until to the treatment 6 that has a total of 22.35. Moreover, in getting the mean, all we need to do is to get the totals and divide with the total number of replications. So 11.1 divided by 4 is equals to 2.76. 13.37 is equals to 3.34. 17 divided by 4 is equals to 4.25, and so on up to the treatment 6 where we have 5.59 as means. So much of that, we also derive the totals of replications. So in replication 1 or block 1, we have 26.4, 26.27 in replication 2, 26.37 in replication 3, and 26.25 in replication 4. So after the presentation of the data, we will now go on to the degrees of freedom where treatment is equals to 6 and replication is equals to 4. So we have 4 sources of variation. First is the replication, second is the treatment, third is the error, and fourth is the total. While on DF, in getting the degrees of freedom of each source of variation, first for replication, all we need to do is to subtract the numbers of replication from 1, where 4 minus 1 is equals to 3, and 3 is our DF for replication. While on treatment, same process on what we do in replication, t minus 1 is equals to 6 minus 1 equals to 5 as our DF treatment. So in error, all we need to do is to multiply the DF of replication and treatment where 3 times 5 is equals to 15 as our DF error. So in total, we need to multiply also the total numbers of replication and treatment minus 1 where we have 4 multiplied by 6 is equals to 24 minus 1 equals to 23 as our DF total. So after that, we will now go on to the F test statistic from F table. So we have four sources of variations. So first is the replication, second treatment, third error, and fourth is the total. And for the DF, we have 3 for replication, 5 for treatment, 15 for error, and 23 for total. And for F-tab, in getting the values of F-tab, we just need to locate it in the F distribution table. And for the replication at 5% or 0.05 level of significance with a DF of 3, we have 3.29 and 5.42 at 1% or 0.01 level of significance. While on the treatment, we have 2.90 at 5% level of significance with a DF of 5 and 4.56 for 1% level of significance. So after that, we will now state the decision rule. So in stating the decision rule, it must be at alpha equals to 5%, do not reject or fail to reject HO if FC is less than FTAB, and reject it if FC is greater than or equal to FTAB. At alpha equals to 1%, do not reject or fail to reject HO if FC is less than FTAB, and reject it if FC is greater than or equal to FTAB.
I am Ivy Jane G. Capuyo from BSA 2H Group 1. Calculate the following. Number 1, grand total. Summation xij is equal to 2.85 plus 2.75 plus 2.80 plus 2.70 plus 5.58 plus 5.65 and so on is equal to 105.29. Number 2, correction factor or CF. So correction factor is equal to summation x squared over n is equal to 105.29 squared over 24 is equal 11,085.9,841 divided by 24 is equal to 461.916 or 461.92. 3. Total sum of squares or TSS. TSS is equal to summation x squared ij minus correction factor is equal to 2.85 squared plus 2.75 squared plus 2.80 squared plus 5.65 squared and so on minus 461.916 is equal to 488.912 minus 461.916 is equals 26.996 or 27. Block or replication sum of squares or RSS. RSS is equal to summation r squared over t minus CF. 26.4 squared plus 26.27 squared plus 26.37 squared plus 26.25 squared over 6 minus 461.916 is equal to 2,771.512 divided by 6 minus 461.916 is equal to 0.003. TRSS is equal to summation T squared over R minus CF. 11.1 squared plus 13.37 squared plus 17 squared plus 22.32 squared plus 19.15 squared plus 22.35 squared minus 461.916 is equal to 1,955.394 divided by 4 minus 461.916 is equal to 26.933 or 26.93.
Hello, I'm Ivan Greg Katipay. So, error sum of squares is expressed by TSS minus RSS minus TRSS. The error sum of square is obtained first by computing the total sum of square, the replication sum of square or block, then the treatment sum of square. Then, if masolve na nimong tulo, then makakam up din kani nga mga numbers. So, 26.996. Then, for the replication sum of square is 0.003. Treatment TRSS 26.93. So, 26.996 minus 0.003 minus 26.93 is equals to 0.06. So, replication mean square. So, the replication mean square obtained by first computing the replication sum of square and the replication degree of freedom. So, for the replication sum of square is we have 0.003, then for the replication degree of freedom is 3. So 0. So if 0.003 divided by 3 is equal to 0.001. So treatment mean square or the MSTR. So the treatment mean square is expressed by TR is treatment mean square divided by degree of treatment. So if masolve nimo ang treatment sum of square and degree of freedom of treatment, so makakam up ka nga mga numbers. So 26.93 divided by 5 is equals to 386, or you can round it off to 5.39. So number 9, error mean square or the MSE is expressed by MSE is equals to ESS, or the error sum of square divided by the error degree of freedom. So if first thing you do is solve the error sum of square and the degree of freedom from the error of the error, then makakam up din gani nga number 0.06 divided by 15 is equals to negative 0.004. So number 10, F computed or FC. So for both replication and treatment. So first for the dito mag-una sa replication. So the F computed of replication is expressed by MSR, or the mean or the replication mean square divided by error of mean square. So if maka-come up na ka na maka-solve na ka na nila, then ning MSR and MSE, so mo rin na yung number nga mo gawa sa 0.001 divided by 0.004 is equals to 0.25. So for the treatment, so F computed of treatment is expressed by MSTR, or the treatment mean square divided by the error mean square. So 5.3086 divided by 0.004 is equals to 1346.5.
So in letter J, give the summary of the ANOVA. So I am Eliza E. Valdez from section BSA 2H. In RSV, the replication, the treatment, error, and total. In our replication with the DF, or the degrees of freedom, is 3, the treatment is 5, the error is 15 with a total of 23. In RSS, or sum of squares, in our replication, we got the 0.03. So, in there, we got that from the block or replication sum of squares or RSS, which we square the total replication and minus it to the CF or the correction factor. So we get the answer of 0.003. In our treatment, it is 26.933. Okay, we got them the totals of every blocks in every treatment. In every treatment, which is 11.1, 13.37, 17, 22.32, 19.15, and 22.35. We squared them and minus them to the CF or our correction factor, that we got the answer of 26.933. In error, which is 0.06, we got the TSS, which is 26.966, the RSS, which is equals to 0.003, and the TRSS, which is equals to 26.93. So ESS equals 26.966 minus 0.003 minus 26.93 is equals to 0.06. In our 26.996, so in there, it is our sum of squares. So we sum the 2.85, we sum them, and then got the answer of 488.912. We minus to the CF, which is 461.916. We got the answer of 26.996. Our MS, in the replication, which is 0.001, we got them using RSS, that is equals to 0.03, and our replication degrees of freedom, which is equals to 3. So MSR equals 0.003 divided by 3 is equals to 0.001. So next is the 5.386. So we got them using or given the TRSS, which is 26.93, and the DF of treatment, which is 5. So MST or equals to 26.93 divided by 5 equals 5.386. So in 0.004, which is the error mean square or MSE, the given that ESS is equals to 0.06 and the DF error is 15. So MSE equals 0.06 divided by 15 equals 0.004. In our FC, we computed the FC of replication, which is 0.001 divided 0.004, which equals to 0.25. That is for the FC of replication. And the FC of treatment is equals to 5.386 divided by 0.004. That is equals to 1,346.5. In our F-tab, in the replication for 5% is 3.29, in 1% is 5.42, and in our treatment for 5% is 2.90, and in 1% is 4.50. 56. So, in K, letter K, state your decision regarding the hypothesis. So, blocking. The null hypothesis is not rejected since the observed FC is less than 5% of the tabular F value with 3 and 15 degrees of freedom 3.29. The null hypothesis is not rejected since the observed FC is less than 1% of the tabular F value with 3 and 15 degrees of freedom 5.42. Treatment. The null hypothesis is rejected since the observed FC is more than 5% of the tabular F value with 3 and 15 degrees of freedom, or 2.90. The null hypothesis is rejected since the observed FC is more than 1% of the tabular F value with 3 and 15 degrees of freedom, 4.56. Make an interpretation and conclusion. Blocking. HO is not rejected. The FC value is less than the F tab at the 5% level of significance. The effect of blocking is not significant, designated by NS. Thus, the effect of the blocks and the response variable are the same. Treatment. HO is rejected at 1%. The FC value is greater than the F tab at the 1% level of significance. The effect of treatment is highly significant. Thus, the effect of the treatments on the response variable is highly significant.
Hello, good afternoon everyone. My name is Annalyn Amor Salva. Today I will report the last part of this activity, the co-op calculate the following. So this is my report. Number 1, coefficient of variation, or CV. We are going to find the percent. So this is the formula. Square root mean squared error over sample mean times 100. So square root 0.004 divided by 4.387 times 100, so equals 1.44 square percent. So mao na siya ang percent nga itong ginapangita sa CV. So the second one is standard error of the treatment mean. So sample mean square root mean squared error, or MSA, over R. So 0.004 over, or divided by 4, equals 0.03. Then the next one is standard error of the difference between treatment means. So the formula is ST square root 2 mean squared error, or MSA, over R. So 2 is squared times 0.004 divided by 4, or over 4, equals 0.04.
And that would be all. Thank you.